Lesson 2, College Algebra 2, Circles, Definition of Functions and Related Topics. The standard form of a circle is x minus h, that quantity squared, plus y minus k, that quantity squared, is equal to r squared, where r is the radius and h comma k is the center. So we have a picture below. We have h comma k is the center, that's the blue dot. We have a radius shown, and it goes to the point x comma y, which is part of the circle. And we will derive this formula by using the distance formula. So the radius is equal to the square root of the difference of the x's, x minus h squared, plus the difference of the y's, y minus k squared. And then we got r is equal to the square root of this stuff. So how do we get to the next line? We can square both sides. So r squared is equal to the square root of that stuff squared, and the square root of wiggle squared is wiggle. Wiggle is all that stuff inside the radical, so we got x minus h squared plus y minus k squared is r squared. Here we have 4 equations involving circles. We're to identify the center and the radius. In our first one, we have x plus 7 squared, and we're looking for x minus a number. Now we can write x plus 7 as x minus a minus 7. So in the h comma k, h is negative 7. Y minus what number? 2. It's already given to us. And what positive number do you square to get 16? That would be 4. So we're finished with that one. Now we look at number 2. We have x minus 6 squared plus y minus 5 squared is equal to 7. So this is easy. X minus what number? 6. Y minus what number? 5. What do you square to get 7? Positive number, the square root of 7. Square root of wiggle squared is wiggle. Now we have x plus 1 squared plus y plus 2 squared is 36. The radius is easy. The positive number that you square to get 36 is 6. We're going to change x plus 1 to x minus a minus 1. Y plus 2 to y minus a minus 2. So the center is negative 1 and negative 2. Our next problem does not look like a square plus a square equals a square. It's x squared plus 12x, and y squared plus 4y is 20. What we're going to do is to complete the square twice. So x squared plus 12x, we want to add a number to that to make it a square. And the way we do it is we take half of 12 is 6, so x plus 6 squared. If you add 6 squared to the top, that's 36. X squared plus 12x plus 36 is x plus 6 squared. And if we look at y squared plus 4y, we take half of 4, that's 2. And y plus 2 squared is y squared plus 4y plus 2 squared is 4. Now in doing this, we've added 40 to the left-hand side of the equation. Now we have to add it to the right-hand side of the equation. So that would give us 60. So we still got to do the minus bit on the x plus 6 and the y plus 2. So the center would be negative 6 and a negative 2. And the radius would be the square root of 60. It can be simplified, but we'll just leave it as the square root of 60. Here we have a problem. The center of a circle is the midpoint of the line segment from 2, 7 and 10, 9. So those 2 points will be on the circle. And then it says find the center and the radius. The center would be the midpoint. The midpoint formula is you add the x's and divide by 2, and you add the y's and divide by 2. So we have 2 plus 10 over 2 and 7 plus 9 over 2. That's 12 over 2 and 16 over 2, which is 6, 8. And that's our center h, k. Now the distance between 2 points, that's going to be the radius between the center and either 2, 7 or 10, 9. So when we do the points 6, 8 and 2, 7, doesn't matter which one comes first. So we look at the first radius formula, and that's 2 minus 6 squared, that's the x squared, plus 7 minus 8 squared, that's the y squared, and that's negative 4 squared, 16 plus 1, which is the square root of 17. Now if we choose to do the center 6, 8 to 10, 9. We have 10 minus 6 squared plus 9 minus 8 squared. And that gives us the square root of 16 plus 1, which is the square root of 17. Another person does this. They find the distance from 2, 7 and 10, 9. They're going to find the distance of the diameter that goes through the center 6, 8. So it's 2 minus 10, the square root, plus 7 minus 9 squared, the square root of all that stuff, and that's square root of 64 plus 4. And we have to divide by 2 because the radius is half of a diameter. Now, that's the square root of 68 over 2. And 68 is 4 times 17. So we can say the square root of 68 is the square root of 4 times the square root of 17. And the square root of 4 is 2. So the 2 comes out and the 2's cancel and we get the square root of 17. That's another way of doing it. So you don't actually have to know the center to actually find the radius. We will now define what a function is. Now, we have two sets, x on the left and y on the right. And for each member in the set x, there can only be one value in the set y, so we say that's a unique value. So in our example, the smiley blue face goes to the year 1959. The smiley green face goes to the year 1031. And the smiley red face goes to 1972. So if I tell you what color the smiley face is, you will know what the year is. That is a function. It's a unique value in the set y. Now in this example, we have a relation that is not a function. We start with the year in the set x, and we have 1959. And we see we have two smiley faces in the set y. That's not a unique smiley face in y. In 1972, that gets set to 1, a green face, but in 1031, that goes to 3 smiley faces. But the key is there's at least one value in the set x that goes to more than one value in the set y. It is not a function, but it is a relation. In this example, we have two sets, and we're going to ask, do either of the sets represent a function? Now, in the top one, we have points. X is on the left, y is on the right. Now, 2 goes to 3, 3 goes to 4, 4 goes to 5, 5 goes to 6. We know where each of the x values, 2, 3, 4, and 5, go to. But the set on the bottom, we're first told that 2 goes to -3, and then we're told that 2 also goes to 3. The same with 4 goes to -5, and also 4 goes to 5. This cannot be a function. It is a relation, but not a function, because each x does not have a unique value for y. In this example, x represents questions, and the set y are various tests. So the questions are A, B, C, D, and E, and the tests are 1, 2, 3, and 4. And we're asked, does this represent a function? And the first thing we see, A could be on test 1, and A could also be on test 3. That can't be a function because we found a value in the set x that goes to more than one value in the set y. That's the test. Here we have an example of a function. We'll call it a real function. Most people just say function. And the rule is we can only put real numbers in for x, and the numbers that come out have to be real numbers. What are real numbers? You can think of them as all decimal numbers, and they're split into two groups. Rational numbers, they're all repeating fractions or fractions that terminate, like a half is 0.5. And repeating numbers, you could have 1/7, that's 0.142857, 142857, it goes on forever. And then you have other numbers that their patterns don't repeat, and that would be like the square root of 2, the square root of 3, the square root of 5, the square root of 6, the square root of 7, the square root of 8. You can do the square root of any integer that's not a perfect square, and that's and irrational numbers, and their decimals do not repeat as far as you go out. They will not repeat. Now we got two things. Our equation is y is equal to x squared. So we put in a number for x, we square it, and we get y. It's also written in functional notation. Y is equal to, and you read this, f of x. Don't say f paren x paren. It's read f of x. And the formula is, it's x squared. So if we let x be 3, then y is equal to 9. If x were equal to -3, -3 squared is also 9. That's okay for each x. We know where y is going to. And we call the domain, they're the numbers that can be used, and they're the numbers in the x set, and the range is numbers in the y set. So for our domain, we could say it's -infinity to infinity. You can put any number in for x, any real number, or you could say all numbers. The range, now that's the y values, and so we have to say, now what's the lowest y value? Well, the lowest value that you could get for x squared is 0, because if you put a negative number in and you square it, you will get a positive number, and 0 squared is 0. So we could say the range is bracket 0. That means you include the 0, and you can go to infinity. You can't actually get there. That's why it's a parentheses. Or you could say all y greater than or equal to 0. Here is a graph that has a little wiggle in it in the middle, and it does not represent a function. For the value of x equal 2, we look at the black curve. The red line hits it in 3 different places, and this is called the vertical line test. We could draw other red lines if we're on the left side of the y-axis. That's up and down. It only hits it in one place, but there's an x, namely 2, that it hits it in more than one place. So for x equal 2, you have different values for y, and so it cannot be a function. So when you have a graph, you can use the vertical line test to see if you have a function. So from this, we would see if we drew a circle would not be a function. So for a given x, you might have 2 different values for y. Here we have a graph of a function. It starts on the left. X is -9, and the height is -5. Grows through the x-axis at -7, -1, and +3. These are X-intercepts. We notice the Y-intercept, where it touches the y-axis, that's y is equal to -4. And we have typical questions: what's the domain, what's the range, and things are like that, and that's on the next set. Here we have our graph again, and we have typical questions that would be asked. Now, find the domain. That is x values. The leftmost dot is at -9, and the y value is -5. And the rightmost dot is at 5, 3. The x value is 5, so it goes from -9 to 5, and it's brackets because we include the points. What's the range? The lowest value is -5, and the highest value is at x is -2. The y value is 4, so it's bracket -5, bracket 4. Find the x-intercepts. Where do you touch the x-axis? -7, -1, and 3. Where do you touch the y-axis, the y-intercept? -4. Now, f of 2, is it positive or negative? You put your pencil at x equal 2, you must go down to get onto the graph, so that is negative. F of -4. What's the height? So we go 1, 2, 3, 4. Put your pencil at -4, and you would go up to your graph, so that is positive. And then we have a question: what's the value of x? So that you put x in, the formula gives you 4. And if we look at our graph, we see when x is -2, we get the height of 4. So f of -2 equals 4. X is equal to -2. Now, to answer the question about the domain, with a fractional expression, you cannot divide by 0, so you ask yourself the simple question: What makes x minus 3 0 when x is 3? So the domain is all x except x equals 3. Here we have the answer to the second question. Find the x-intercepts or intercept. Now this is a fractional expression. The only way you can get 0 in a fraction, when's y 0, when do you touch the x-axis, is when the numerator x plus 21 is 0, and that's relatively simple. If x is negative 21, you get negative 21 plus 21 over negative 21 minus 3. That is 0. So the x-intercept is x is equal to negative 21. That's when y equals 0. Here we answer the third question. Find the y-intercept. Where does the curve touch the y-axis? That's when x equals 0. So this is simple. Y is equal to f of 0. Just plug in 0. That's 0 plus 21 over 0 minus 3. 21 over negative 3 is a negative 7. So when x is 0, the y value is negative 7. Here we have the answer to the fourth question. Find f of 6. That is easy. Y is equal to f of 6. Wherever you see x, you put 6. So we have 6 plus 21 over 6 minus 3. That's 27 over 3 equals 9. Here we have the answer to the last question. What's the value of x so that when you plug in x, f of x gives you 2? So we have x plus 21 over x minus 3 equals 2. Let's clear the denominator. Multiply both sides by x minus 3. So x minus 3 times x plus 21 over x minus 3. The x minus 3's will cancel out, equals 2 times x minus 3, which is 2x minus 6. So we see below x plus 21 is equal to 2x minus 6. You get the x's on one side, the numbers on the other side. When you go across equal, you change the sign. So if you move the x from the left-hand side over, it's negative x, and you move the negative 6 over, it's plus 6, so x is equal to 21. We want to check our answer. 21 plus 27 is 48, and 27 minus 3 is 24. So 48 over 24 is 2. So we found the x value that you get 2. Finding the x-intercepts with functions. That can be rather difficult. Here we have a simple looking function. It's a polynomial. F of x is, you see the x is 6 plus 16x to the 4th plus 41x squared minus 154. And what's normally written in the literature is that you're supposed to take the divisors of the leading term. That coefficient is 1, and the number term, negative 154, all the possible divisors, positives and negatives. Only problem here is 154, that's 2 times 2 times 2 times 19. There are a lot of different possibilities. You spend a lot of time on this, plugging numbers in or using synthetic division, or you can do division with tuples the way I do it. It could take you too long, but you could find none of them work. But you would plug in numbers, and you would find out if you plug in 2, plug in negative 2, you will get the same height. So this curve is actually symmetric about the y-axis. And it has real solutions, 2 of them. They happen to be the square root of 2 and minus the square root of 2. And that's why the curve on the graph here hits around 1.4. But the other 4 solutions have I in them. So you're not going to see that. And this looks like a cup. And if we use tuples to get an idea of what it looked like, we would do f of 0, f of 1, f of negative 1. That's just working with the coefficients, f of 10 and f of negative 10. If you take the coefficients and turn them into an integer, that is f of 10 and f of negative 10. Wherever you see an odd exponent, you would change the sign. Well, there are no odd exponents, so you would get the same number. And that would give you a rather quick approximation of what the curve looks like as an estimate. And that would be a lot faster than plugging in numbers from negative 2 up to 2 and incrementing them around 0.1 each time. That's very tedious. So the tuple approach is much faster. But the point of this piece right here is that finding y-intercepts are simple. Just plug in 0. finding x-intercepts can be rather difficult.